So we are going to solve exactly the questions exactly in the same manner how you should have solved in the ISI entrance, or how you should solve in the ISI entrance. Or okay, so we'll pick the easy questions first and then gradually see the difficult questions. So first of all, let's come down to the marks analysis. So this is the topic-wise marks analysis this year for UGA ISI entrance. Calculus of one variable, there was a total of 44 marks consist of calculus of one variable. Algebra, there was 32 marks. This time algebra was the second most important topic. Number theory, there was 12 marks, which means say there were each questions consists of like carries 4 marks obviously. So from calculus of one variable there were 11 questions. From algebra there were 8 questions. Okay, and then the third most important topic was number theory and trigonometry. Some very standard questions, some standard questions like came from number theory which were confusing. Combinatorics, this time combinatorics was of 8 marks. And geometry, coordinate geometry and probability consist of 1 question each. So obviously this carries equal weightage. Okay. Now the next is the UGB, the subjective paper. Subjective paper, there were 3 questions of calculus from calculus of one variable. 3 questions which was of 30 marks. Combinatorics was of 10 marks. Algebra 20 marks. There was one mixed question which was one like integer, and which like it's mixed question in the sense mixed question means a combination of 2 topics or 3 topics. There was one mixed question and one geometry question, and that too plane geometry. So today we are going to discuss this UGA, which is the objective type paper. So objective type questions we are going to discuss. Okay. Chalo. So let me just change this ink color to yellow. Otherwise, you won't be able to see in this black. So find the. So in this case, you are going to find the sum of all the solution of this equation. This equation. Now, this was one of the most easiest question. 99% of you have done this correct. 99% of you have done this correct. This is 2 plus log x minus 2 base 2 equals log 8x minus 2 base. So that's in the base. Okay, and so we are going to simply solve first. We are going to simply solve for x first. Okay, then we are going to see the domain later. So since they have mentioned that we have to find the sum of the solutions in this particular interval 2, infinity. So first let's solve this. Okay, for this to solve this, what we can do is let's consider this log x minus 2 base 2, this to be y. Let's say this is equals to y. Then we have 2 plus y is equals to, how much is this? This is log 8 base x minus 2. Log 8, that's 8 is 2 cube. So basically this is 3 upon y. This is 3 upon y, isn't it? This is log 2 cube. 8 is what? 2 cube, right? 3 comes in the front. So basically we are having 3 by log. This is 3 upon log x minus 2 base 2, right? This is by the properties of logarithm. So basically what we are having is, now we can simply solve for y. This is very basic equation. Now you can simply, I'll solve it over here. So basically this is y square plus 2y minus 3 is equals to 0, which means this is factorize this. This is a very basic equation. So y plus 3 multiplied by y minus 1 is equals to 0. So basically y is minus 3 or y is equals to 1. Now what was y? Y was log x minus 2 base 2. So basically this is log x minus 2 base 2, this is basically equals minus 3, and log x minus 2 base 2 equals 1, right? And we solve for x. This is how much? So this is x minus 2 equals x minus 2. This is log, now we have base 2, so this becomes 1 by 8, right? X minus 2 is equals to 1 by 8. X minus 2 is equals to 1 by 8. And from here we have x is equals to 17 by 8. 17 by 8, that's around 2.125. So that's so this belongs to 2 comma infinity, this interval 2 comma infinity. 17 by 8, so that's around 2.125. Okay, and this is x minus 2. This is x minus 2 equals, this becomes 2 to the power, that's 2 only, right? So that's 2 only. X minus 2 equals 2. So basically x is equals to 4. And this also belongs to this interval, which is 2 to infinity. Right? That is also 2 to infinity. So what they have asked in the question is, you are asked to find the sum of all the solutions in this particular interval. So both of these values belongs to 2 to infinity. Now you just simply find the sum. So sum is what? Sum is 17 by 8. 17 by 8 plus this is 4. This is ultimately this is 49 upon 8. 49 upon 8. So in this case, C is obviously the right answer. 49 by 8. Okay, next one. Next one is you are asked to find the value of this summation. This summation 1 plus 1 upon 1 plus 2 plus 1 upon 1 plus 2 plus 3 plus and so on up to 1 upon 1 plus 2 plus 3 plus and so on up to 2021. Okay, and this is once again a very basic problem. Once again, all of you have done this correctly. So this is, let's solve this. So basically here we have let's first represent this in terms of summation. This is summation n is equals to 1 to 2021, right? This is 1 upon 1 plus 2 plus 3 and so on up to plus n. So this is basically summation n is equals to 1 to 2021. If you see the denominator, this is 1 upon n into n plus 1 divided by 2. Some of the first n natural numbers, that's n into n plus 1 by 2. Okay, so this is basically, if you take this 2 outside the summation, this is 2 into summation n is equals to 1 to 2021, and this is further you can just rewrite this 1 by n into n plus 1. Okay, you can break this into the form of 1 by n minus 1 upon n plus 1. Okay, in terms of partial fraction, you can break like this: n plus 1 minus n, so n and n gets cancelled, so that's 1 upon n into n plus 1. Okay, and this is a very basic summation series which you have done, right? It's a telescoping series. It's a telescoping series. Obviously, you have done this quite a few times. It's a very basic telescoping series, and I have said that in case of these type of telescoping series, what is the summation? Summation in this case, 2 into, first is the summation goes from what? N is equals to 1 to 2021, right? So basically the sum will be what? The sum is 1 minus n is 1. So 1 minus 1 upon n plus 1. So that's basically 2021 plus 1, which is 1 upon 2022. Okay, this is a very basic sum. You like, in case you want to see the expansion of this, you can just simply put the values. The terms will get cancelled. It's a telescoping series. Only the first and the last term will be there. Okay, the first and the first value and the last fraction will be there. Let's say you put n is equals to 1. So this is 1. Okay, 1 minus 1 by 1 plus 1. So that's 2. This is the first term. Second one will be what? Second is n is equals to, you put n is equals to 2. So this is 1 by 2 plus, sorry, minus 1 upon n plus 1. So that's 2 plus 1. So 1 by 3. Next term will be 1 by 3 minus 1 by 4 and so on. Okay, so 1 by 2 gets cancelled, 1 by 3 and 1 by 3 gets cancelled, and so on. So you will be left with 1 and the last term, which is minus 1 by 2022. Okay, now just simply we have to just simplify this. So this is twice of 1 minus 1 upon 2022. So this is 2021 divided by 2022. So this is ultimately this is 1011. So that's 2021 divided by 1011. So in this case, option C is correct. Option B, sorry, option B is correct. 2021 divided by 1011. The number of ways one can express 2 square, 3 cube, 5 to the power 5 and 7 to the power 7 is a product of two numbers A and B, where GCD of A and B is equals to 1. One more condition given is that 1 is less than A and less than B. So we have to find the number of ways in which we can represent this number, which is 2 square, 3 cube, 5 to the power 5 and 7 to the power 7, and certain conditions are given that we'll see. So basically we have to represent this number in terms of the product of two numbers A and B in this manner, A and B. Okay, so and where GCD of AB is equals to 1, and one more condition, that is 1 less than A less than B is given. Okay. Let's say, let's take this number to be n. Let's take this number to be n. Okay, so basically now for this 2 square, for this 3 cube, for similarly for this 5 to the power 5 and similarly for this 7 to the power 7, we'll have two choices each, right? So basically we have two choices for this, two choices for this, two choices for this, and two choices for this. That's 2 to the power 4, so that's 16 ways. Total we have 16 ways, but there are certain other conditions as well. Now out of this you should have two more ways which we have to discard. Those are, let's say these two numbers A and B. A can take 1, B can be n. Similarly, A can be n and B can be 1. So that's two cases, right? This A can be 1, this A can be 1, this A can be 1, B can be n. Similarly, this A can be n, B can be 1. But we have to discard this case. We have to discard this case. Okay. The reason is because of this 1 less than A less than B, this criteria, because of this 1 less than A less than B, obviously, which means A is greater than 1. A is greater than 1, obviously. So basically we have to discard this case. So which means these are two cases. So discard two cases, which means now we have 14 ways. Now we have 14 ways. Now out of this 14 ways, let's say this n, which is AB, which means we have to represent this into the form of product AB. This number A and B are distinct, although this n is equals to AB is the same as BA, but because of this condition A less than B, exactly half choices will satisfy. Exactly half choices will satisfy. So basically the correct answer is 14 by 2 ways. Final answer is 14 by 2, so that's 7. So the number of ways is 7 in this case. So option C must be correct. When we were doing the method of iteration process, at that time I have showed you this method, this particular equation, this particular relation rather, we have seen over there. We have seen lots of questions, not the same actually, not this. We have seen similar questions, how to bring into how to use the iteration process over there. So the same thing we are going to use over here is, so see here, f of x plus 1 is half fx. This thing is given. F of x plus 1 is half of fx. This is given. So now what you are going to do is put x is equals to x plus k minus 1. Okay. Now why shall we just put this in the form of x plus k minus 1? The reason is this will be in the form of x plus k then. Okay, and then we can use the iteration process to find out the relation, general relation. So see the f of x plus k, this becomes f of x plus k equals half into f of x plus k minus 1. Okay, similarly you will have the next is half square f of x plus k minus 2. Okay, and so on. You will have half to the power k f of x. You can also verify this by induction. Now let us see what they have asked to find. Now what is given? an is integration 0 to 1, 0 to n fx dx for all n greater than or equals to 1 integers. So basically we are asked to find this limit n tends to infinity an. So limit n tends to infinity an, and this is summation k is equals to 0 to infinity integration 0 k to k plus 1 integration k to k plus 1 f of x dx. Okay, so we use this substitution to solve this integral, to simplify this integral rather. So what you're going to do is we are going to simply put x is equals to z plus k. Put x is equals to z plus k. Then dx is what? Dz. Dx is dz. Okay, and if we change the range, when x was k, when x was k, then z should be, z now will be 0. When x was k plus 1, z now will be 1. Okay, so this is now summation k is equals to 0 to 1. Summation k is equals to 0 to infinity integration z is equals to 0 to 1. We're changing the range, and this becomes f of z plus k, f of z plus k dz. Okay. So from here we are having now from this relation f of x plus k, from this relation f of x plus k, we can find out what is f of z plus k. Right? We can easily find out what is f of z plus k. What is f of z plus k? F of z plus k, from here this is 1 upon 2 to the power k f of z plus k. F of z 1 upon k, 1 upon 2 to the power k f of z. Okay, so this is basically summation k is equals to 0 to infinity. This is 1 by 2 to the power k f of z dz. Okay, and I hope this thing we have done quite a few times. This is just a normal infinite GP series, right? This is a normal infinite GP series, right? And what is the sum of this? 1 upon 1 minus half, which is 2, right? 1 upon 1 minus half, so that's 1 upon half, and that is 2, right? So this is basically 2 into integration 0 to 1 f of z dz. And you know that if we change the variable without changing anything, so it is the same as integration 0 to 1 fx dx, right? So basically option D should be correct. ABCD is greater than 0. These are all real numbers. Then the maximum possible value of cx plus dy over all points on the ellipse x square divided by a square plus y square divided by b square is equals to 1 must be what? Okay, so the maximum possible values of cx plus dy over all points on this ellipse x square by a square plus y square by b square is equals to 1 on this ellipse. Okay, so basically we can get this x and y from this from the points which are there in this ellipse. So there are two processes like using which we can do this question. Okay, both of them will save your time. One, you take any point on this x and y on this ellipse, a cos theta and b sin theta, any point on this ellipse. Let's say a cos theta and b sin theta. Any point on this ellipse, let's say a cos theta and b sin theta. Okay, and obviously this this point we are taking on this ellipse, right? So this x and y, so the value of x and y, right? And so that we can just conclude from here that basically we have this, what this is, x and y, the values of x and y. Substitute this, this is AC cos theta, and this is BD sin theta, this is BD sin theta, and this is, you know that this is what, in case you have done trigonometry very well, then you can just simply solve this. You know that this is, what is the maximum value of this? This is AC square, maximum value of this is AC square, A square C square plus B square D square, right? In this case, A is the right option. There is one more method, and that would be a more accurate method. There is one more approach. You can write this Cx plus dy. In case you don't know what is the Cauchy-Schwarz inequality, for the Cauchy-Schwarz inequality states that, let's say a1, a2, or any a1, a2 and an, and b1, b2, and let's say up to bn. For this Cauchy-Schwarz inequality, we have a1, b1 plus a2, b2, and so on up to an, bn. An, bn is less than or equals to a1 square plus a2 square, so on up to an square, multiplied by, this is again b1 square plus b2 square, and so on up to bn square. This is the Cauchy-Schwarz inequality. Okay, this is a Cauchy-Schwarz inequality, and using this inequality you can definitely solve this. How will you solve this? Using this inequality, I'll use a different pen. Using this, we are going to solve this. Let's see. So Cx plus dy, we can represent this Cx plus dy in terms of let's say a into c into x by a, right? Because we have to utilize this condition as well. So basically this is x square upon a square plus y square by b square is equals to 1. You have to use this condition as well. So ac into x by a plus b into bd into x by b, so that this a and a gets cancelled out and this b and b gets cancelled out. So this is less than or equals to, use this Cauchy-Schwarz. So why we are doing this? To bring this into the form of a1 b1 plus a2 b2 and so on up to a and bn. So this is a1 b1 in the form of a1 b1 I'll take. Okay, so a1 b1 a2 b2. So basically this is less than or equals to square root of a square c square, right? This is a1, this is b1, this is a2, this is b2. So this is a square c square plus b square d square multiplied by, once again, so what is b1 square? B1 square is x by a whole square plus x by b whole square, x by a whole square plus x by b whole square. And you know the value of this is what? The value of this is 1. This is 1. So basically this is what? Ultimately this is ultimately Cx plus dy only. We are rewriting this Cx plus dy in the form of this, just to bring out, just to apply this Cauchy-Schwarz inequality. So Cx plus dy, this is less than or equals to square root of a square c square plus b square d square. So what is the maximum value? Maximum value of this is square root of a square c square plus b square d square. Okay, I hope this is clear. Okay, so in this case, option A is correct. Clear? Then the next one. Next one is from functions. Consider this to be a question of calculus only, because you all do functions under calculus only. So basically fx is sin x plus alpha x, where x belongs to r and r is a fixed real number. Then the function f is 1 to 1. It's 1 function, injective. If and only if alpha is, what are the possible values of alpha? What are the possible values of alpha? Okay. So what are the possible values of alpha? You have to decide from here. Now you know that it's a 1 function. Okay. It's a 1 function. If you go by the calculus method, it has to be either increasing or decreasing. Right? Either increasing or decreasing. F prime of x is greater than or equals to 0. F prime of x is less than equals to 0. So basically, if we apply that method, f dash x, let's find f dash x. What is f dash x? Differentiate. So this is after differentiating, this is cos x plus alpha. This is cos x plus alpha, and this is greater than or equals to 0. And second case is cos x plus alpha is less than equals to 0. Okay. So we'll prove that this to be monotonic. In this case, what? In this case, alpha is greater than or equals to minus cos x, right? And what is the maximum value of this? Maximum value of this is 1. Maximum value of this is 1. And what is the maximum value of this? This is alpha less than equals to. Similarly, you will get what? Alpha less than equals to. This is minus 1. Right? Alpha less than equals to minus cos x. In that case, when alpha is less than equals to, so basically if you rewrite this, let's rewrite this, alpha is less than equals to minus cos x, and when alpha is less than equals to minus cos x, this is less than equals to minus 1. Right? Okay. So basically your B option should be correct. I think. X plus 2 mod y plus 3 mod z less than equals to 6. Very few students have done this correctly. Those who have done this, that's fine. Let's try out this thing. Now, first of all, how to find out the volume? There are lots of methods as well. There are two methods. One is the shortest way, is just without using calculus. This can be solved like with using calculus as well. With integration also, we can solve this. But that will be a more complicated part. Let's not go into that. This is what? This is a, first of all, it's a question of 3D. It's a question of 3D. Basic 3D. Okay. And quite a few times we have done this inequality in 3D, mod of x plus mod of y, like this. You have done some inequalities in 2D. In 2D, you have done this type of inequality. The same thing they have given in 3D. Mod x plus mod twice of mod y plus 3 into mod x less than equals to 6. And this is what? This represents a tetrahedron. This represents a tetrahedron this way. Let's say if I draw the octants. Let's say if I draw the octants, this is a tetrahedron. This way, somewhat like this. It's a tetrahedron, and we are asked to find out the volume of this region. This volume of this region. And here, the volume of a tetrahedron is what? The volume of a tetrahedron is, see, first of all, we'll consider one octant and we'll multiply it by 8, because there are 8 octants. After all, at the last we'll multiply it by 8. So volume of this tetrahedron is 1 by 6 into A into B into C. This is the volume of the tetrahedron. You are asked to just simply find the volume of the tetrahedron. Okay, and volume of this tetrahedron is what? 1 by 6 into ABC. A is what? A is 6, B is 3, and C is 2. So this is basically 1 by 6 into 6 into 3 into 2. That's basically 6. And this is of one quadrant. This is of one quadrant. Okay. So the total volume is what? The total volume is 6 into 8, because there are 8 octants. There are 8 octants. quadrant. So we call this as octants in three-dimensional geometry. There are total 8 octants. I think all of you know this, that there are 8 octants, right, formed by the XY, YZ and the ZX plane. So total volume. So total volume is what? Total volume is 8 into 6. So that's 48. 48 should be the right answer. So total volume is 6 into 48. That's 40. 6 into 8. So that's 48. This should be the total volume of this region. In case you have marked option B, then you're totally correct. Okay, next question. Achha, next question from calculus. Let f such that R2R be a twice differentiable function such that this is a d2fx upon dx2, d2fx upon dx2 is positive for all x belongs to R. Now, first of all, first thing which will come to your mind, this is given d2fx divided by dx2. What is the meaning of this? d2fx by dx2, this is positive for all x belongs to R. First of all, this is given, right? d2fx divided by dx2, this is given to be positive for all x belongs to R. This means double derivative, and double derivative represents concavity. And what is the meaning of this? This means concave upwards, like this, concave upwards, right? So this is concave upwards. And few more informations are given. We can draw the curve and see. Let's just draw a rough sketch of the information that's given. So basically f of 0 is 1 and f of 1 is 4. Which of the following is not a possible value of f of 2? Which of the following is not a possible value of f of 2? Now f of 0 is 1. Okay, f of 0 is 1 in this case. So here we have f of 0 is 1. So this point is 0, 1, right? And we have f of 1 is 4. F of 1 is 4. Somewhere over here, let's take 4. F of 1 is 4. This is 1, 4. Okay. Now, simplest curve is, let's join this with a straight line. That's the simplest way of joining this. Okay, let's join this with a straight line. And what else is given? Keeping in mind this curve fx, see fx is concave upward. So basically the thing is, this will change its concavity. This will change its concavity. Okay, like this. This will change its concavity like this. Okay. And we have f of 2. So basically f of 2 is this one. Okay, f of 2. At 2 we have f of 2. So basically we can find out this point. We can find out this point. Okay, let's say this is 2 comma anything. You take this this point as 2 comma m, right? We can easily find out this point. Okay, we can easily find out this point. We have 0 comma 1. In between we have 1 comma 4 and we have 2 comma m. M minus 1 divided by 2 is equals to 3. In that case, we'll get m is 7. This point is 7. This is a rough sketch we are drawing. So this point is 7. Right? The thing is, they have said that which of the following is not a possible value of f of 2. So this function, this is obviously fx is concave upward. Fx is concave upward. Obviously, this f of 2 will be greater than 7 in this case. From this diagram only, you can see that f of 2 is greater than 7. Right? F of 2 is greater than 7. Obviously, this cannot take 7. This cannot take 7. Okay, so how shall we just solve this? So what they have given actually? So let fx is e to the power minus of mod x. Fx is e to the power minus of mod x, where x belongs to all real numbers. G of theta is given to be integration minus 1 to 1 f of x upon theta dx. where theta is not equals to 0. And you are asked to find out this limit theta tends to 0, g of theta divided by theta. You're asked to find out this. Okay. So first of all, what is given is g of theta is integration minus 1 to 1 f of x upon theta dx. Theta obviously not equals to 0. This is first of all given, right? So for what is f of x is e to the power minus of mod x. Obviously f of x upon theta is e to the power minus of mod of x upon theta, right? So basically we have integration minus 1 to 1 e to the power minus of mod of x upon theta dx with respect to x dx. Okay. And obviously, first of all, the first property which will come to your mind is the odd even function wala property, right? Integration minus a to a fx dx. Obviously, the first property which will come to your mind is your odd even function property, right? So first of all, this is an even function. It's an even function, obviously. So you can multiply with the 2. This is 2 into integration 0 to 1 e to the power minus of x upon theta d theta, x upon mod theta d theta, right? Because this is even function, obviously you can take out this mod. So this is minus of x upon mod theta d theta. Okay, so basically we can simplify. Sorry, this is dx, not d theta. This is dx. Okay, this is with respect to x and not with respect to theta. So basically we are having integration e to the power minus, integration goes from 0 to 1 e to the power minus x upon mod theta dx. Okay, so this is a very basic integration. This integration is you consider this to be a constant. Mod theta is obviously is considered to be constant. So this is twice of e to the power minus of x upon mod theta divided by minus of 1 upon mod theta. Basic integration this is, and here x goes from 0 to 1 is the range of this integration. So you can simply put this range of integration and then simplify. That's all. So this is twice of if you just simply put this range of integration. So this is going from 0 to 1. So you put x is equals to 1. So this is basically, and you take this minus 1 upon mod theta outside this. So basically you can write this. You can write this as 2 into mod theta multiplied by, this is e to the power minus of 1 upon mod theta, and this is e to the power 0. So that's basically 1. Right. So this is after all 2 mod theta, and here we have e to the power minus 1 upon mod theta minus 1. So what we can do is, oh, there was one negative sign. There was one negative sign as well. This negative sign. So we can multiply with this negative sign. So this becomes 1 minus e to the power minus 1 upon mod theta. We can multiply with this negative sign. Okay. So this much calculation we have done. Fine. And what else? What else we are asked to find? We are asked to find the value of this g of theta by theta. So we have evaluated what is g of theta. Now find what is g of theta by theta. Limit theta tends to 0. G of theta by theta. Simply divide this by theta and find what is limit theta tends to 0. Right? I'll do it over here. So basically theta tends to 0. Limit, this is limit theta tends to 0, and g of theta divided by theta. So this is ultimately, this is limit theta tends to 0, and this is g of theta. So that's 2 mod theta divided by theta multiplied by 1 minus e to the power This is 1 up minus 1 upon mod theta. That's what we are getting. Okay. And basically, most of you have what you have done is, most of you have marked this option C as correct, but C is not the right answer. The first thing which will strike is this D will strike to your mind. This option D, the limit may not exist. Whenever you see this option, whenever you see this type of options, obviously that means that you have to check both the left hand limit and the right hand limit. Both the left hand limit and the right hand limit. Limit theta tends to 0, 2 into mod theta divided by theta multiplied by 1 minus e to the power minus 1 upon mod theta. So that's basically theta tends to 0. Now this 1 minus, see this 1 minus e to the power minus 1 upon mod theta, theta tends to 0. This will not create any problem, right? This will not create any problem. Theta tends to 0. This anyways tends to 0 only. When theta tends to 0, this will anyway tends to 0 only, because theta tends to 0, this tends to 0. Anyways, for the left hand limit and the right hand limit, for both the cases, this will, which means for 0 plus and 0 minus, this thing, this term will tend to 0 only. This term will tend to 0 only, right? So the term will create is, which term will create the problem? Here, this term will create the problem, this one. 2 mod theta divided by theta. Check the left hand limit and the right hand limit. Obviously, you can see, you don't need to check even. Obviously, you can see that this will have 2 different limits, right? This will have 2 different limits. Obviously, you can see, although it's a very basic limit form, if this tends to 0 for all the cases, you just need to simply check this. This is either plus 2 and minus 2. The left hand limit, right hand limit will not be the same. In this case, the limit does not exist. In this case, the limit does not exist. Next one. Consider the curves x square plus y square minus 4x minus 6y minus 12 is equals to 0. So what is this? This is a circle. Obviously, you can rewrite this. This will be uploaded in the right. This is x minus. This is x minus 2, x minus 2 whole square plus. If you rewrite this, this is x minus 2 whole square plus y minus 3 whole square is equals to, this is equals to 5 square, radius 5. Okay, this is of radius 5. Acha, what else you have? You have a 9x square plus 4y square minus 900. 9x square plus 4y square minus 900. 9x square plus 4y square minus 900 equals to 0. So this is basically an ellipse. It's basically an ellipse. And what else you have? You have one more curve. Acha, one more curve is there. Y square minus 6y minus 6x plus 51 is equals to 0. And that is a, if you rewrite this, this is, if you rewrite this, this is basically, let me use a different pen. If you rewrite this, then this is y square minus 6y minus 6x plus 51 is equals to 0. And this is basically, if you rewrite this, then this is y minus 3 whole square. And what else? This is 6x minus 6x minus 42. So that's 6. If you take 6 common, then this is 6 into x minus 7. So the vertex of this parabola is what? The vertex of this parabola, vertex at 7, 3. And what else we can see from here? So the vertex is 7, 3. So basically what we can do is we can draw the figure now. We can just simply draw the figure, because they have asked for the maximum number of disjoint regions into which these curves divide the xy plane, excluding the curves themselves. Okay, excluding the curves themselves, the maximum number of disjoint regions into which these curves divide the xy plane. So we can draw the diagram first. First of all, we have a circle. Okay, whose radius is 5. okay, whose radius is 5. Like this, we have a circle whose radius is 5, and then we have a ellipse. It's an inverted shaped ellipse, like this. You will have an ellipse like this. Okay, you will have an ellipse like this, and now, first of all, the center of this, what is the center of this? The center of this circle, center is at 2, 3, right? Center is at 2, 3. We have the center at 2, 3, and what else? We have the radius. Radius is 5. Okay, radius is 5. Center is at 2, 3. Let's say over here, somewhere over here, you have the center 2, 3. Radius is 5. Radius of this is 5. And so obviously, if you have the parabola, so in this case, the radius is 5. So in case you have this parabola, vertex at 7, 3, right? The vertex will be at 7, 3. The parabola will be like this. The parabola will pass like this. Like this. Because the vertex is at 7, 3. Vertex is at 7, 3. Obviously, parabola will pass like this. Vertex is 7, 3. Vertex is 7, 3. Radius is 5. So we have the circle like this. Okay. So the thing is, they have asked for the number of, this point is 7. This is 7, 3. They have asked for the maximum number of disjoint regions into which these curves divide the xy plane. Okay, these curves divide the xy plane. So what is the maximum number of region? So what are the regions first? Let's find out the regions first. So this is one region. This is one region. Let's use a different pen. This is one region. Let's say this is one region. This is one region. This is another region. This is one more. This is the fourth region and the fifth region. Excluding the curves themselves, obviously we have 5 regions. Excluding the curves themselves. Right, so basically we have total 5 regions. Answer will be what? 5. Maximum number of will be what? 5. Maximum number of disjoint regions. They are saying maximum number of disjoint regions. Obviously 5 from this. So 5 is the right answer. A box has 13 distinct pairs of socks. PR denote the probability of having at least one matching pair among a bunch of R socks drawn at a random from the box. And if R0 is the maximum possible value of R, so R0 is the maximum possible value of R, such that P of R is less than 1, PR is less than 1, then you have to find the value of PR0. Obviously, R0 is what? R0 is the maximum R, maximum possible value of R. Obviously, R0 can be 13, right? R0 can be 13. R0 can be 13, right? So basically, now we are asked to find PR0. PR0. So how to find PR0? So basically, PR is what? PR is the probability of having at least one matching pair among a bunch of R socks drawn at a random. Right. So what is PR0 is? PR0 must be 1 minus. It's at least. So basically, what we are going to find is PR0 in this manner is 1 minus. So obviously, the total possible cases is 26C13. And now in this case is what? So here we are going to take, so how many cases? So first we can choose 13 pairs out of this 13, we have 13 pairs. So basically 13C13, right? And any sock in 2 ways, right? So any socks in 2 ways. So each socks will have 2 ways, so which means 2 into 2 into 2 into 2 up to 13 times. So that's 2 to the power 13. So this is basically 1 minus 13C13, so that's 1, and this is 2 to the power 13 divided by 26C13. Obviously, this is option C. So we have this question now, and it's a question which is based on complex numbers. A is one set which is 1 by z such that mod of z is equals to 2, and B is one set which is 1 by z such that mod of z minus 1 is equals to 2. So A and B are two sets. Let's redefine this particular set. So first, in the first set, which is A is given to be 1 by z such that mod of z is equals to 2. This is set A. So basically we have mod of z is equals to 2. So here this means z is 2 into e to the power I theta. Now in terms of 1 by z, if I say that let's say 1 by z is w1, 1 by z is w1, and that is basically, so 1 by z is what? 1 upon 2 into e to the power I theta. So which is basically half into e to the power minus I theta. And so this is basically mod of w1. Mod of w1 is half, and this lies on a circle once again. So this lies on a circle. So this lies on a circle. So w1 lies on a circle. So which means so this lies on a circle, and basically, so which means A is a circle. A is a circle. So we now come to set B. In set B, we have 1 by z such that mod of z minus 1 is equals to 2. So basically from this part, mod of z minus 1 is equals to 2. We have basically from this part, we have z is equals to 1 plus 2 into e to the power I theta. From this part, we'll get z is equals to 1 plus 2 into e to the power I theta. Now suppose if I take this 1 by z now over here, which is, let's say this is w2. 1 by z is w2. So this is 1 by z is, in that case, this is 1 upon 1 plus 2 into e to the power I theta. Okay. So we can simplify this. Let's simplify this and find out the value of e to the power I theta from here. Okay, so that we can take the mod on both sides. So w2, let's say if we cross multiply this, so this is w2 plus 2 into w2 e to the power I theta is equals to, this is equals to 1. Okay, so that's what we are having. So we can solve for e to the power I theta from here. So e to the power I theta, this is 1 minus w2, 1 minus w2 divided by 2 into w2, 2 into w2. That's what we are having. So now we can take the mod on both sides, and this becomes 1 minus w2 divided by 2 into w2. Like if I take the mod on both sides, so this is 1 minus mod of 1 minus w2 divided by 2 into w2 is equals to 1. Okay, and so that we can just take this 2 over here on the right hand side, and obviously this becomes a circle. So B is also a circle. So in this case, A is also a circle and B is also a circle. So in this case, option C is correct. A and B both are circles. At A, B, C and D before non-negative real numbers where A plus B plus C is plus D is equals to 1. The number of ways one can choose these numbers such that A square plus B square plus C square plus D square is equals to max of A, B, C and D. Okay. Achha. So this is A square. So this condition is given that A square plus B square plus C square plus D square is equals to max of A, B, C, D. Max of A, B, C, D. So this is the condition, and what else is given? A plus B plus, this is the main thing which is given, A plus B plus C plus D is equals to 1. And this condition, which is A square plus B square plus C square plus D square is equals to max of A, B, C, D. Okay, so we are going to consider certain cases for this particular problem. Let's one by one analyze those cases first. So the first case you consider, the first case here we consider the first case in which we first say that is equals to C is equals to D is equals to 0. Fine. In that case, A is equals to 1. In that case, A is equals to 1, right? In that case, you will have the pair like this, right? 1, 0, 0, 0. Like this, you will have this pair. So there are 4 cases possible, right? So there are 4 cases possible. 4 cases are possible, right? So basically, why 4 cases? Because let's say in this case, A is equals to 1, the rest can be 0, right? Similarly, if you see one more case like B is equals to 1, the rest can be 0. Similarly, C is equals to 1, the rest of the things can be 0. Similarly, D is equals to 1, rest of the things like A, B, C are all 0. Okay, so basically there can be 4 possible cases. 4 possible cases in this case. So A is equals to 1. Next is A and B. Next case is, in this case, A and B is not equals to 0, and but C and D is equals to 0. A and B is not equals to 0, and C and D is equals to 0. In that case, what will we get? So if C and D is 0, so obviously A plus B is equals to 1. C and D is 0, so A plus B is equals to 1. So basically, we are getting A plus B is equals to 1. And what else? And from this part, let's say by assumption, if you take one assumption, so by assumption we can say that A is greater than B. Okay, let's say we'll consider one assumption that A is greater than B. Okay, so if A is greater than B, by this assumption we can say that A square plus B square is equals to A. A square plus B square is equals to A. Okay, from this part, maximum of A and B. Okay, so basically A square plus, so what we're getting is A square plus B square is equals to A. A square plus B square is equals to A. And A square plus, so basically what we'll get, so B square we can just write this B square as 1 minus A whole square is equals to A. That means if we simplify this, then we'll get 2A square plus 3A plus 1 is equals to 0, which means A minus 1 and 2A minus 1 is equals to 0, right? Clear with this? This is minus, sorry, this is minus 2A square minus 3A plus 1. So if you factorize this, then this is A minus 1 and 2A minus 1, which means A is equals to 1, A is equals to 1, and A is equals to half. A is equals to 1 and A is equals to half, right? Out of which we can't take this case. We can't take this case. We have to reject this case. The reason is if A is equals to 1, then B is equals to 0 at that time, right? A plus B is equals to 1, right? From here, if A is equals to 1, then B is equals to 0, right? And that is not possible because A and B is not equals to 0, we have considered. So basically, A cannot be equals to 1. And if A is equals to half, this case satisfies already. If A is equals to half, then B is equals to 1. So B is equals to 1 minus half, right? So that's half only. Okay, so A is half and B is half, C is 0 and D is 0. So we get the pair like this. We get the, not a pair, we get the, or you can consider this to be one, what you can say, a triplet. For triplet, you have 3 elements, A, B, and C. This is, you'll get the pairs like this: 4, 1, half, half, 0, 0. Right? Similarly, you can get, how many cases can be there? How many cases can be there? A is equals to half, B is equals to half, the rest are 0. Then this is one case. The second case can be A is equals to half, then A is equals to half, then B is equals to anything. You can take A is equals to half, let's say C is equals to half, and the rest of the things can be 0, right? So basically, so how many cases can be possible? 6 cases. Why 6 cases? 4C2, right? So total there are 4C2 cases. Obviously there are 4C2 cases. So 4C2 means what? 6 cases. For this we have 6 cases. So for this second case we have Total 6 cases. For the first, we have 4 cases. What else? Now we have one more case, the third one. Let's see the third one as well. The third case is, in the third case, A, B, and C is not equals to 0 and D is equals to 0. A, B, and C is not equals to 0 and D is equals to 0. This means A plus B plus C, A plus B plus C is equals to 1. Right? D is equals to 0. ABC is not equals to 0. So A plus B plus C is equals to 1. And what else? And by that assumption, we have considered that A is greater than B. So by that assumption, we can say that A square plus B square plus C square is equals to A. Right? So similarly, you can go by that same procedure. You will get A is equals to 1/3, B is equals to 1/3, and C is equals to 1/3. Right? A is equals to 1/3, B is equals to 1/3, C is equals to 1/3. So accordingly, we'll have how many cases? 4C3. Right? Accordingly, we'll have 4C3 cases. A is equals to 1/3, B is equals to 1/3, and C is equals to 1/3, and this is 0. So accordingly, if you see, there will be 4C3 cases for this one. 4C3. So this is basically 4. So total 4 cases. And lastly, we have one last case, the fourth one, where A is not equals to, B is not equals to, C is not equals to D. This is our final case. In this case, obviously, A square plus B square plus C square plus D square is equals to A. Right? Obviously, accordingly, you will similarly, by this pattern, you have understood that what will be the next case. Obviously, there will be only one case, which is 1/4, 1/4, 1/4, and 1/4. In this case, A can be 1/4, B can be 1/4, C can be 1/4, and D can be 1/4. And how many cases for this one? Only one case. There will be only one case for this one. So the previous one, there were 4 cases. 4 cases plus the next was 6 case. 6 cases were there. Then we have 4 more cases, and then 1 case. So 4 plus 6, so that's 10 plus 5. So all total there are 15 cases. So the number of different ways one can choose these numbers are 15. So now this is once again a very standard question compared to the others, and what we feel is this is a bit challenging question. And obviously, first of all, this second order differential equation is given. Second order differential equation, that's x squared d2fx upon dxy dx2 plus 4x dfx upon dx plus 2fx. This second order differential equation, and that too with variable coefficient. X squared. So that's a variable only. So basically what we can do is now first one more thing is given, one more condition is given, that is f of a is equals to 0 is equals to f of b. This condition is given. So which of the following options are correct? So first of all, we have x square d2fx by dx2 plus 4x dfx by dx plus 2fx. And for simplification, let's say we can, for our calculations to be easier, so we can just simply write this as x square f double prime x plus 2x into f prime x, right? We can break this 4x dfx upon dx to 2x dfx upon dx plus 2x dfx upon dx. We can break this 4. And why should we break this? Just now you will see that how we can reduce this if you just break this 2x dfx upon dx. So basically we can write this as plus 2x f prime x, and then you have plus 2fx, plus 2fx. So basically what you can do is, in this case, if you carefully observe this term, x square f prime f double prime x plus 2x into f prime x. And this is what? This is, let's say this is d by dx of x square into f prime x, isn't it? This is the d by dx of f prime x square into f prime x, right? Plus this is d dx of, this term is what? 2x into f prime x plus 2 into fx. So this is the derivative of 2x into fx, isn't it? This is the derivative of 2x into fx, right? Clear with this? That's what we can simplify, and that's given this to be greater than 0. This is given already. This is greater than 0, right? So this is greater than 0. So basically, we have done these type of simplifications in differential calculus, in the classes of differential calculus quite a few times. These type of simplifications of reducing into the form of this differentiation, we have done this quite a few times. So this is basically the derivative. The derivative is what? In this case, now what you can do is, so ultimately, so this is d by dx. So this is ultimately d by dx. If you combine this, so this is x square f prime x. Simplify this. So this is x square plus 2x f of x. And this is greater than 0. This is greater than 0. Right? So that's given. Finally, if you see that you can reduce this as well, x square f prime x and 2x fx. Obviously, just by observation, just by mere observations only, you can just simply see that this is derivative of x square f of x. This is x square f of x. So basically, we are having d2 by dx2 of x square f of x. This is greater than 0, right? So the double derivative of x square fx is greater than 0. This is what we are having. So what we can conclude from here is, any double derivative, you know, this we can conclude that this is concave upward because the double derivative is greater than 0, obviously. So we can say that this implies this function x square f of x, this function x square f of x is concave upwards like this. This is concave upwards. The double derivative is greater than 0. Obviously, this function is concave up. A square f of a square f of a is what? A square f of a is 0. You just simply put x is equals to a. Okay, because the condition is given, this condition that f of a is the same as f of b is the same as 0. This is same as 0. So from here we'll get a square f of a is 0 and b square f of b is 0. B square f of b is 0. This thing we are getting. Okay. So if we draw the rough sketch of this graph, this, so x is equals to a and x is equals to b is one of the roots of this equation. So basically, if we have like this and we have this to be concave upwards, so basically you will have the equation like this. The graph, actually, the graph will be like this. This is a and this is b, and this is concave upward. The graph will be like this, in this manner. Just a rough sketch of this graph, right? The graph will be like this. Obviously, x square f of x is less than 0, right? Obviously, x square f of x is less than 0. From here, x square f of x obviously less than 0. Which means what? Which means fx is also less than 0. Fx is also less than 0. Which means fx is negative for all x belongs to open interval AB. 15th. The polynomial x to the power of 4 plus 4x plus c is equals to 0 has at least one real root if and only if which of the following conditions? C is less than 3, less than equals to 3, or what? So which of the following conditions? Now this is a very basic question. This is a very basic question. All of you have done this correctly, I hope. So this is fx. Let's say fx is this polynomial x to the power 4 plus 4x plus c. Okay, this is the, let's say this is the function fx. Now this has at least one real root if and only if which of the following is correct, right? If you can just draw a rough sketch of what we are talking about, then you can easily just simply solve this. Just a rough sketch of what we are just simply talking about. So obviously in this case, you can see that there is only one point of minima. One point of minima will be, obviously there will be a minima only. The reason is if you find f prime x is what? 4x cube. F prime x is 4x cube plus 4, right? And you equate it to 0, which is x is equals to minus 1. X is equals to minus 1. You will get x is equals to minus 1, right? And this is on the only point of minima. This is also you can verify, although it's a very basic question. F double prime x, what is f double prime x? This is minima. So we have minima at x is equals to minus 1, right? So now we can simply draw the curve and see. Just a rough sketch of this idea what we are trying to find out. Obviously over here you are getting one more thing we have to find out. So that what is f of minus 1 at this point, at the point of minima, what is f of minus 1? F of minus 1 is minus 1 to the power 4. So that is 1 minus 4 plus c, right? Which is c minus 3. C minus 3. Obviously the graph will be somewhat like this. There is the point of like this. Just a rough sketch I'm drawing. So at minus 1 we have the minima. Obviously this c minus 3 will be what? This c minus 3 will be less than or equals to 0. C is less than equals to 3. Right? C is less than equals to 3. At minus 1 we have minima. Obviously c minus 3 is less than equals to 0, which means c is less than or equals to 3. And most of you have done this correctly. We now move on to question number 16. And it's a question of permutation combination. The number of different ways to color the vertices of a square PQRS using one or more colors from the set red, blue, green, yellow, such that no two adjacent vertices have the same color. So let us solve this question. So basically you have the colors. The colors are red, blue, green, and yellow. So these are the set of colors which we are having. And so what they have asked to find is to find the number of ways to color the vertices of the square using one or more colors from this particular set, such that no two adjacent vertices have the same color. No two adjacent vertices have the same color. So if I say that, let's draw a square over here. Let's draw a square over here. Let's say this is PQRS. Let's say PQRS. Okay. So obviously, let us say that this square PQRS is and you have to find the number of ways just to color the vertices of the square, this particular square, such that no two adjacent vertices have the same color. So for this vertex P, so for vertex P, how many choices we are having? We have 4 choices. Out of this red, blue, green, and yellow, we have 4 choices, right? Because we can fill up this vertex with any one color. So we have 4 choices for this. Okay. So for this P, for vertex P, we have 4 choices. So basically, now, so let us take this a fixed color. Let us take this to be a fixed color. Let us say, now let us any color. Let's say this takes red. This takes red. Okay. So if this P vertex takes the red color, okay, if this takes the red color, Okay, so basically if this takes the red color, then this vertex Q, so Q can take either of blue, green or yellow. This Q can take blue, green or yellow, right? So for that we have 3C1 cases, right? So 3 cases, so obviously 3C1 choices. So in this case, so for Q we have 3C1, so that's 3 choices. So we have 3 choices. Now suppose once again we use the same logic. Let us take any color fix, make any color fixed for this vertex Q. Let us take blue. Let us take blue. Okay. Let's say we take blue over here. So which means the next color, which means the next case actually, the next vertex R will have 2 different cases. R will have 2 different cases. This vertex R, for vertex R, will have 2 different cases. One is either this can be read, or this cannot be read. Okay, so there are 2 possible cases. If this can be read, this may be read, or this may not be read. Accordingly, we have to solve this. So basically, in case of red, if this is red, then obviously for the next we have 3C1 choices. In case this is red, say, for the next we have 3C1 choices, right? And if this is not the red color, if this vertex does not take the red color, then what? If this is not red, then obviously this will take 2, so this will have 2C1 cases. If this is not red, obviously we have 2 choices left, green and yellow. Obviously we have 2 choices left. If this is not red, we have 2 choices, which means green or yellow, right? So for that we have 2C1 cases. Okay, so the total number of ways will be total number of ways is 4C1 multiplied by 3C1 into, so now basically, so now what you are having is now 1 into 3C1. For the first case we are having 1 into 3C1, and 1C1 into 3C1, so that's 1 into 3C1, so that's 3C1, so that's 3 only, 3, and plus you're having this 2C1 choices into 2C1 choices, 2C1 choices into 2C1 choices into 2C1 choices. So basically 2C1 into 2C1, so that's 2 into 2, 4. So that's basically 4 plus 3, so that's 7. This part is 7. So 4 into 3, so that's 12 into 7. 12 into 7, and that is 84. Then there comes this question. This is once again a very good question which I have seen so far. And obviously case of number theory you can consider. It's a question on number theory. In this question, it says that you have A, which is PQ plus P square plus P plus 11. Let's say this is PQ plus P square plus P plus 11. This is A, and B is P square plus 11. P square plus 1, sorry. P square plus 1. Right, so here what we are having is this is PQ plus P square plus P plus 11, and A is what? A is, so what we can do is we can simplify this. Okay, we can simplify this as, let's factorize this. So this is P square plus 1, and this is P plus 1 plus 10. Okay, we can factorize this, and what else is given? D is the GCD of AB. D is the GCD of AB. The set of possible values of D is what? Right, the set of possible values of D is what? Now, first of all, here D, which is the GCD of AB. First, what we'll do is let's find the factors of 10, because this GCD, this depends on this 10. Okay, this depends on this 10. So D, which is the GCD, let's find the factors of 10 GCD of AB, because this D divides 10. This D divides 10. Okay, this D should divide 10. So this GCD of AB. So basically, if we find the factors of 10, so this is 1, 2, 5, and 10. Okay, and also they have mentioned P is prime. P is prime. P is any prime, and so basically, if P is 2, see, if say P is 2, right? If P is 2, then what is A? Let's say if P is 2. If P is 2, then what is A? A is 5 into 3. A is 5 into 3 plus 10. And B is what? B is 2 square plus 1. So that's 5. B is 5. Right? And GCD of this is what? So this is 15 plus 10. So that's this is 15 plus 10. Okay, so this is 25. And GCD of this is what? So GCD is obviously from here only you can say that the GCD of A and B is what? In this case, GCD of A and B is 5. Now you know that except 2 all are odd primes, right? Except 2 all are odd primes. Except 2 all are odd primes. Because 2 is the only even prime. Except 2 all are odd primes. Right? And what you have is if except 2 all are odd primes, and you know that what else we can say, that B is P square plus 1. This is B is P square plus 1. This is always even. B, which is P square plus 1, this is always even. Fine. B, which is P square plus 1, this is always even. Also, this thing A, which is P square plus 1 multiplied by P plus 1, this is also an even. And 10 is the number which is also an even number. So this is even. This is also even. Right? Even plus even. So obviously you can see that GCD at least cannot be 1. Right? GCD can't be 1 at least. So what we can do is we can start omitting the cases. GCD can't be 1 at least. So here we have the set of possible values of D. So where we have 1, this case can't be correct. This case can't be correct. Obviously this case also can't be correct. So obviously B is correct. Right? So GCD can't be 1 at least. Because they have asked for the set of possible values of D, GCD can't be 1, so obviously B is the correct option. Right? Yeah, see, you are considering all 2 cross 2 matrices whose entries are distinct and taken from this set 1, 2, 3, 4. You have to find the sum of determinants of all such matrices. And this is a problem which is comparatively much more easier than the others. So first of all, you have a 2 cross 2 matrix. Let's say this matrix you are considering PQRS. This matrix you are considering PQRS. Okay, and all these elements of PQRS are coming from in this set. This set, which is 1, 2, 3, 4. Okay, all these PQRS elements are coming from this set 1, 2, 3, 4. Right? So basically, how many cases you will have? There will be 24 cases. Why? Because there are 4 factorial cases. 4 factorial. Why? Because 4 members and there are 4 elements and there are 4 positions. So obviously, the number of cases is what? The number of cases will be 4 factorial. Right? So basically 4 factorial, which means 24 such matrices. Right? So there are 24 such matrices. Right? And for any matrix, if you see, for any matrix, let's say if you consider this matrix, let's say let's say this is 1 2 3 4. For any matrix, you can interchange the columns as well, right? Let's give this by a bar, or by this a dash. Let's give this as a dash. Let's give this as a dash, like this. So this is, if you interchange, we can interchange the column. Let's say this is 2 4 1 3, right? We just simply interchange this column. And what is this? This is, if you take the determinant of a is negative of determinant of a bar or a dash, right? This is by the property of determinant, right? So if you see that, so for all the cases, if you see, the sum of determinant will be what? The sum of determinant will be 0 only. The sum of determinant will be 0 only for all the cases. If you check for the rest of the cases, the sum of determinant will be 0 in only, right? Sum of determinant will be 0 only in this case. So what is the answer? So answer is 0. Answer is 0. This is once again a very basic question. Next one. So f is a function, so it's defined from R to R, and it's a twice differentiable function such that its second derivative is continuous, and dfx upon dx is not equals to 0 for all x belongs to R. So limit x tends to 0, fx upon x square is equals to pi. Then which of the following are correct? Let's work out this. So basically you have dfx upon dfx upon dx. This is not equals to 0 for all x not equals to 0. What else is given? You have limit x tends to 0, fx upon x square is equals to pi. Now this is given. What we can do is, so basically we can derive the condition that limit x tends to 0, or the L'Hopital's rule, limit x tends to 0, f prime x by 2x, this is equals to pi, from which we'll get limit x tends to 0, f double prime x divided by 2, that is pi, right? And obviously from here what we can get is, clearly we can get f double prime of 0 is 2 pi, right? And this is one of the standard results which we have done in class. F double prime of 0 is equals to 2 pi. From this derivations we can derive this. So basically, and what else? Obviously you will get one more result from here, which is f prime of 0 is equals to 0. Obviously f prime of 0 is equals to 0. These two important results will help us doing these problems. So basically we are getting two results from here, which is f prime of 0 is 0 and f double prime of 0 is equals to 2 pi. Anything else we can say? F of 0 is 0 as well. F of 0 is also 0. When x tends to 0, f of 0 must be 0. F of 0 must be 0. One more result, which is f of 0. Obviously f of 0 must be 0. So basically you have f of 0 to be 0, f double prime of 0 to be 2 pi, and f dash 0 is 0. Fine. So what is the meaning of this thing? F prime 0 is equals to 0. This means what? This means x is equals to 0 is a point of minima, because this is f double prime of 0 is what? F double prime of 0 is 2 pi, which is greater than 0. So this is obviously a x is equals to 0 is a point of minima. This we can conclude from here. It's a point of minima, isn't it? So it's a point of minima. So basically if we draw a rough sketch of the graph, just draw a rough sketch of the graph. Obviously also This f double prime of 0 is equals to 2 pi. This will be concave upwards, right? This will be concave upward. So basically, you're having the graph of the function like this. The graph will be like this. This is a rough sketch of the graph. At 0, we have f of 0. This is a rough sketch of the graph. Right? This is the rough sketch of the graph. Obviously, f of x is what? F of x is greater than f of 0. Obviously, this is quite obvious. F of x is, we'll have f of x is greater than f of 0. Clearly, option A is correct. Okay, clearly option A is correct. So, f of x is greater than f of 0. Okay. Next question. Number of integer solutions of this equation x square plus y square, x square plus y square plus x minus y is equals to 2021. X square plus y square plus x minus y is equals to 2021. So there are lots of methods of solving this question. Let's say if this is x square plus y square, let's subtract 2xy on both sides. Okay. So this is, if you subtract 2xy, I'll write this directly. If you subtract 2xy, so this is what? So this is x minus y whole square, x minus y whole square, and this is x minus y, right? And here we have 2021 minus 2xy. So that we can balance from both sides, we are subtracting 2xy on both sides. Okay. The reason why we have done this because see, we can get a particular argument from here from which we can decide the number of solutions at least. See, x minus y, this x minus y, here we have x minus y whole square and here we have x minus y. And 2021, this is 2021, you know that this is odd number, this is odd number, and this is an even number. 2 into x by 2 into something is even only, this is an even number. Odd minus even, odd minus even is odd, right? So basically in this case, this is even. Okay, this is if x in between x minus y, this x minus y has to be even or has to be odd, right? In case this is even, we have even plus even. We have even plus even. In case this is odd, we have odd plus odd. We have odd plus odd. In case this is even, we have even square, so that's even only, and this is even square, this is even only. And in case this is odd, odd square is odd only, plus this is x minus y, we are assuming this to be odd, so this is odd only. So even plus even, we have even, we know even plus even is even, and we know that odd plus odd is also even. So this means even is equals to odd, even is equals to odd, right? Obviously this is not possible, so 0 solutions, right? Okay, the next one. The number of different values of a for which the equation x cube minus x plus a is equals to 0 has two identical real roots. The question on identical roots, okay, and that two identical real roots. Identical real roots, let's say if this is the function, if this is your function fx is equals to 0, let's say if this is fx is equals to x cube minus x plus a is equals to 0. Obviously, identical roots, when an equation is having an identical roots, so basically you will have, let's say if alpha is the root, okay, alpha is the two identical roots, okay, alpha and alpha, let's say. So f of alpha, in this case f of alpha will be 0, this will be 0. Also f dash alpha will be also 0, this will also be 0. This will satisfy this, this alpha will satisfy f of x is equals to 0 and f dash of x is equals to 0. So in this case, what we are having, so what is the function? This is fx. So what is f dash x? F dash x is 3x square minus 1, right? And what is f dash of alpha? F dash of alpha is 3 alpha square minus 1. Equated to 0, you will get alpha is plus minus 3, 1 by root 3, plus minus 1 by root 3. So basically, alpha is 1 by root 3. Alpha can be 1 by root 3 and alpha can be minus 1 by root 3. These are the possible cases. When alpha is, you simply put x is equals to alpha in this equation. So you will get alpha 1 by root 3 whole cube minus 1 by root 3 plus a is equals to 0. Okay. And minus 1 by root 3 whole cube minus alpha, sorry, minus, this is minus obviously plus 1 by root 3 and plus a is equals to 0. That's what you are getting. Now simply solve for a. Okay, from here you just simply solve for a. Obviously you can see that there are two different values of a. What is the answer? 2. Answer is what? 2. Two different values of a. Next one. Achha. So for a positive integer n, the equation x square is equals to n plus y square, where x, y is integers, does not have a solution if and only if. Which of the following options are correct? So this does not have a solution. So we have this equation. First of all, we have x square is equals to n plus y square. So we can say x square minus y square is equals to n, which means x plus y and x minus y is equals to n, right? We are having this. So basically, and what we can do is see if this is now prime number and odd number will have no solution. Now this is a question of same parity, right? They can be both even or both odd. This thing x plus y or x minus y, right? Either they can be both even or they can be both odd, right? And see for this option, let's see for this one, and n is an even number not divisible by 4. If n is an even number not divisible by 4, if n is an even number which is not divisible by 4, obviously if you consider n is an even number which basically which is not divisible by 4 as well, so what you have to consider n to be 4k plus 2. If you consider n to be 4k plus 2, then it's an even number which is not divisible by 4. And further you can break this as, if you take 2 common, then this is 2k plus 1, right? Now this 2 will be acquired by these two of them. So any one of them, right? Any one of them, this will acquire any one of them. So one has to be even, the other has to be, in that case what? In that case one has to be even, and in that case one has to be even and the other has to be odd, right? If this 2 is acquired by any one of them, right? Any one of them, let's say, then one has to be even and the other has to be odd, right? And you know that this question, like this one, this left hand side, this can be both even or both odd. Either they can be both even or both odd, right? So this is where you are having a contradiction. Obviously this does not have a solution if n is an even number which is not divisible by 4. Okay, next one. Now for x which belongs to close interval 0 to open interval pi, the number of solutions of this equation. The number of solutions of this equation, right? So this equation, sine square x plus 2 cos square x plus 3 sin x cos x. Obviously, without even thinking much, the first step is to just simply factorize this. First, you should factorize this. First, you have to find the number of solutions. Sines, this is what? This is sine, if you just break this, let's say this is sine square x plus 2 cos square x Okay, we can break this 3 sin x cos x. We can break this 3 sin x cos x, right? So this is now this is 3 sin x cos x. So we can write this as 2 sin x cos x plus sin x cos x plus sin x cos x plus 2 cos square x is equals to 0. So from here, if you take sin x common, this is sin x plus 2 cos x. Similarly, if you take cos x common from here, then this is sin x plus 2 cos x. This is sin x plus 2 cos x. This is equals to 0. So we have sin x plus cos x. We have sin x plus cos x. And this is sin x plus 2 cos x. That's what we are having. This is equals to 0. So basically sin x plus cos x is equals to 0, which means tan x is minus 1. From here we have tan x is minus 1, and from here we have tan x is minus 2. From this we have tan x is minus 2. So basically sin x, tan x is minus 1 and tan x is minus 2. Right? We can draw the graph and solve this, right? Better is to draw the graph. Very easy, very basic graph. Just draw the graph of tan x in between this interval, because they have mentioned x belongs to what? X belongs to close interval 0 to open interval pi. This interval they have mentioned. Obviously, let's draw the graph in between this interval. So here we have pi by 2, we have pi, 3 pi by 2, and we have 2 pi. Let's first draw the graph of tan x. So we have like this. So 0 to 2 pi, like this, 0 to 2 pi. Then there's a graph in between pi by 2 to 3 pi by 2, like this. Okay, and we have in between 3 pi by 2, we have 3 pi by 2 to 2 pi, we have the graph like this. Here we have open. So this is the graph. Now what? Now we can just simply check this. Now we just simply draw the lines, the two lines, which is minus 1 and minus 2. Right? If we just draw the line through minus 1 and minus 2 like this, obviously you can see that this is minus 1 and this is minus 2. Obviously you can see that there are 2 points of intersection for minus 1 and 2 points of intersection for minus 2 as well. So all total there are 4 solutions, isn't it? The number of solutions is 4. The number of solutions is 4. Number of solutions is 4. In this case, option D is correct. Okay, let's move on to the next question. Now, once again, this question seems to be a difficult one. This functional equation is given. Okay, and these type of functional equations are given, and you're asked to find the value of some conditions are given, and which is that f is differentiable at x is equals to 1, and f of d of fx upon dx, where x is equals to 1 is equals to 2. This is given. First of all, this identity, we have done this quite a few times in the chapter of functions. F of x plus y is fx into f of y. And I have told you at that time that whenever you see these type of identities, you can directly put the answer. You can directly just simply put the options. And obviously you have to directly put here, this is objective type exam. Fx is, f of x plus y is fx into fy. In this case, this is a standard result we have, which is f of x is f of 1 whole to the power x. F of 1 whole to the power x, where x belongs to R. This is a standard result we have done. Acha, what else is given? D of fx upon dx, such that at x is equals to 1, is 2. This is given. So first of all, let's find what is d of fx. D of fx upon dx, dfx upon dx. This is f of 1 whole to the power x into log f of 1, log f of 1, right? And d of fx upon dx at x is equals to 1. You simply put x is equals to 1. So this is f of 1 whole to the power 1, and this is log of f of 1 base e. And that's what you're asked to find actually. If you see, you're asked to find the value of f of 1 log f of 1 base e, isn't it? F of 1 log f of 1 base e. And this is already given that this is equals to 2 only. This is given that d of fx upon dx at x is equals to 1 is 2 only. Right, so this is given to be 2 only. So obviously answer is what? This is 2. Answer is 2. Okay, we move on to the next question. This is a very nice question on trigonometry. This summation k is equals to 0 to 10, 2 to the power k, tan 2 to the power k. This summation is given. Summation k is equals to 0 to 10, 2 to the power k, tan 2 to the power k. Okay. So first of all, if you break this summation, this is 2 to the power 0, so that's 1 only. That's 1, tan to the power 2, tan 2. If you break this summation, you will get 1 into tan 2, so that's tan 2 only, plus 2 tan 2, 2 to the power 1, tan 2 to the power 1, so that's 2 tan 2, plus 2 square, tan 2 square, and so on up to, this will go up to 2 to the power 10, tan 2 to the power 10. Okay. So in the options, you can see there is one extra cot 1, right? So there is one extra cot 1 in each of the options. What you can do is, let's take one cot 1, extra cot 1, and then subtract cot 1. Obviously, we can do this. And from here, what you're getting is, this is tan 1, this is tan 1. From here, what you're getting is, now what we can do is, tan 1, we can take this tan 1 and this cot 1 minus cot 1. Okay, tan 1 and minus cot 1. Let's see. Tan 1 minus cot 1. What is tan 1 minus cot 1? Cot 1 can be the same as, this is same as 1 upon tan 1. So that's tan square 1 minus 1 divided by tan square 1 minus 1 divided by tan 1. That's what we're getting. Tan square 1 minus 1 divided by tan 1. So this is basically tan square 1. So here we have, if you take one extra 2 and take out this minus sign common, let's take this extra 2 and just take out this minus sign common, then this is 1 minus tan square 1 divided by 2 tan 1, isn't it? So this is what? This is basically minus 2 cot 2, isn't it? This is basically minus 2 cot 2, right? That's minus 2 cot 2. So here we have, similarly, if you consider, let's say if you combine, so you now basically you are having minus 2 cot 2. So now you combine minus 2 cot 2 and 2 tan 2. See what happens? Minus 2 cot 2 and 2 tan 2. Right, so we have 2 tan 2. Next is 2 tan 2 minus 2 cot 2. Okay, you keep aside this 2 and then solve this tan 2 minus cot 2. Okay, solve this tan 2 minus cot 2. You will get 2 square minus 2 square cot 2. You will get minus 2 square cot 2. Similarly, you will check for the next term as well. With this and this 2 square, with this minus 2 square cot 2 and with this 2 square, tan 2 square. Okay, with this 2 square, tan 2 square. This is cot 2 square. This will be cot 2 square. Okay, this will be cot 2 square. So this is minus 2 cube. So that's minus 2 cube cot 2 cube. The next will be minus 2 cube cot 2 cube, and so on. So basically, so the last term will be what? The last will be, if you go on in this manner, so the last will be what? Minus 2 to the power 11 cot 2 to the power 11. Right. So for this you have 2 cot 2 in this case, minus of 2 cot 2. Similarly, if you go on, so you are having 2 square cot 2, 2 square cot 2 square. Next will be minus 2 cube cot 2 cube, and so on. If you see, this will go up to minus 2 to the power 11 cot 2 to the power 11. So that is basically, and what else you are left out with? Cot 1. So that is basically cot 1 minus 2 to the power 11 cot 2 to the power 11. Right? So cot 1 minus 2 to the power 11 into cot 2 to the power 11. So what is that? So that is option A. That is option A. A is the right option. Okay. So in this case, in this problem, the main important thing which played a major role is this adjustment, which is plus cot 1 and minus cot 1. And then we are adjusting each and every term with this thing. So first we start with this minus cot 1, and the next term with the next one. Then again the next term with the next this one, and so on. Like this we have adjusted the terms. Here. Next one, 26. You have this function fx, and this question, exactly this question was there in your calculus exam. Exactly this question was there in your calculus exam. The same question, the same options. This was there, and this was given in your previous mock test as well, which took place. Exactly the same questions and the same option. And fx is 1 minus cos x into sine 1 by x when x is not equals to 0, and 0 when x is equals to 0. Okay. Obviously f of 0 is what? F of 0 is 0. So this is continuous or not differentiable. This is discontinuous. So one by one we'll see. So first of all, for continuity, what we do? Let's check the limit. This is x not equals to 0. If you check the limit, very basic question. Limit x tends to 0. This is what? 1 minus, this is 1, which is 0. And this is sine into, this is what? Sine into something 1 upon 0, which is what? Sine infinity. This is again an oscillating value in between minus 1 and 1. This is any oscillating value between minus 1 and 1. So that's basically 0 into an oscillating value, an oscillating number. This is 0 into an oscillating number between minus 1 and 1. So that's basically 0 only. So this is 0. Limit is 0. Function value is 0. So this is continuous. This is continuous. But is this differentiable? Is this differentiable? We can simply find it. F prime 0. What is f prime 0? F prime 0 is limit h tends to 0. This is 1 minus cos. This is 1 minus cos h divided by h square sine 1 by h. That's what we are having. This is 1 by h. Sorry, 1 minus cos h divided by h into sine 1 upon h. Now we can simply find this limit. So this is limit h tends to 0. If you distribute the limit, just simply distribute the limit. This is limit h tends to 0. Limit is distributive. We can simply distribute this. So 1 minus cos h divided by h multiplied by, this is limit h tends to 0, sine 1 upon h. Now sine 1 upon h, this is once again an oscillating value in between minus 1 and 1. This limit is 0. So 0 into sine 1 upon h, 0 into sine 1 upon h, and that's an oscillating value, and that is oscillating value. So this is 0 only. So 0 into any oscillating number which is in between -1 to 1 is 0 only, right? So this function is differentiable as well. This function is differentiable as well. So this is continuous and differentiable as well. But there is no option which is in which you have continuous and differentiable, and its derivative is continuous. This is what they have mentioned. And its derivative is discontinuous or continuous, and its derivative. So which means you have to check 3 cases. One is the continuity, second is the differentiability of this function, and then the continuity of the derivative of this function, which means continuity of f prime x. So find what is f prime x, and then simply check whether this is differentiable or not, or continuous or not, right? If you find out f prime x, and then just simply see what if this is f prime x is continuous or not. Okay, and that is of course a very easy task to do. We have done this quite a few times, right? You will find that its derivative is discontinuous. You will find its derivative is discontinuous. Okay, I'm leaving this step for you. You have to just simply find f prime x, sine 1 upon x. First fx, if you simplify this fx, multiply this, this is sine 1 upon x minus sine 1 upon x into sine 1 upon x into cos x. Okay, and then find the derivative of this, differentiate this, simply find the derivative of this, and just simply check that whether this is continuous or not. You will find this to be discontinuous. In that case, C is the right answer. You will get C is the right answer. 27. Let's see what is this question saying. So the maximum and the minimum values of sine to the power 6x plus cos to the power 6x. Okay, and I have done this question quite a few times. It's a very common question. Sine to the power, first we'll find the maximum value and the minimum value. Sine to the power 6x plus cos to the power 6x, and we can write this as sine square x whole cube plus cos square x whole cube, and we break this into the formula of a plus b whole cube, a cube plus b cube. So this is sine square x plus cos square x whole cube minus 3 sine square x cos square x multiplied by sine square x plus cos square x. So this is 1, this is 1. Ultimately we are left with 1 minus 3 sine square x cos square x. Fine. And to simplify this sine square x and cos square x, what we can do is, let's take one 4 here. So this becomes 2 sine x cos x whole square. So this is 1 minus 3 by 4 into sine 2x whole square. And you all know the maximum value of this, maximum value of sine square 2x, right? Maximum and the minimum value. Minimum is what? 0. Maximum is 1, right? So the maximum value of this is what? Maximum value of this. So maximum value when this is 1 minus 3 by 4 into 0, when this is 1. Okay, and minimum value will be, minimum value is 1 minus 3 by 4 into 1 when this is 1, when sine 2x is 1. So in this case we'll get 1 minus 3 by 4. So that's basically 1 by 4. So you're asked to find, so this is your A, this is your A, and this is your B. Maximum minus minimum, right? A minus B, we can simply now find A minus B, that is 1 minus 1 upon 4, and that is 3 by 4. So 3 by 4 is the right answer. Okay, next question. If two real numbers x and y, satisfy x plus 5 whole square, x plus 5 whole square plus y minus 10 whole square is equals to 196. Then the minimum possible value of this equation, of this identity, that is x square plus 2x plus y square minus 4y is given. So we are asked to find the minimum possible value of this identity. First of all, this first equation, this is a circle whose center is what? Center is at minus 5 and 10. Radius is what? The radius is 14. This is 14 square. Radius is 14. So you have the circle somewhat like this, whose center is at minus 5 and 10, right? So x is minus 5. Somewhere over here you have the center. So this is how the circle looks. This is your circle. Just a rough sketch I'm drawing. This is how your circle looks, and this has a center. Center is at minus 5 and 10. Right. So the minimum possible value of this thing, which is x square plus 2x plus y square minus 4y. So first, it's better if we break this x square plus 2x plus y square minus 4y into the whole square format. So this is x plus 1 whole square plus, we can take this as plus y minus 2 whole square, which is minus what extra terms we have considered? What extra terms? Minus, total is minus 5. Right, so this is basically, there is one more point which is minus 1 and 2, right, which is minus 1 and 2, and this point we have to find the, we shall find the shortest distance of this point from the circle. We have to find the shortest distance of this point. Let's say over somewhere over here you have 1 and minus 1 and 2. Somewhere over here you have minus 1 and 2. So you are asked to find the shortest distance of this point, shortest distance of this point to the from the circle. Shortest distance of this point from the circle. You can join this. Okay. The thing is, basically, we can find this much distance. We can find this distance. Okay, we can find this distance. This is how much this distance is. This is square root of minus 5 plus 1 whole square plus this is 10 minus 2 whole square. How much is that? This is 16 plus 64, right? 16 plus 64. How much is 16 plus 64? Which is this is 4 root 5. 4 root 5. You're getting 4 root 5. Clear? So this distance is, this much distance is 4 root 5. Now we can find this distance QR. Okay, we can find this distance. Okay, let's say this distance is QR. Let's say this is P, this is Q, this is R. We can find this distance QR. Easily we can find this QR. What is QR? QR is what? QR is, you can find it. What is QR? QR is the total radius, right? 14 minus 4 root 5, this thing, isn't it? This is the center. This is the center, right? This is the center. So this total distance is, so this total distance is what? 14. Radius is 14. So 14 minus 4 root 5. 14 minus 4 root 5. This is QR. This distance is 14 minus 4 root 5. Clear with this? So this is 14 minus 4 root 5. So 14 minus 4 root 5 is your QR. Clear? So what you need actually, you need this thing. You need QR square minus 5, right? You need QR square minus 5. Right? So you need QR square minus 5. What is that? So this is 14 minus 4 root 5 whole square. 14 minus 4 root 5 whole square minus 5. Okay, now you just need to simply solve this. Right, you just simply need to simplify this. If you simplify this, you'll get the answer. Whatever after simplification, you'll get the answer. In this case, option A is correct. Option A is correct. You just need to simplify this. I'm leaving the simplification on you, so you can just simply simplify this. Okay. Okay, 29th one. 29th question, where we have this fractional part and this greatest integer part. Okay. So here we have limit n tends to infinity, 3 plus 2 root 2 whole to the power n, under which you have a fractional part. So this thing, these type of problems we have done in limits, as well as it's a proper application of binomial theorem. First of all, the fractional part of this thing, let's say capital F, this is 1 minus 3 minus 2 root 2 whole to the power n. Okay, you know that this thing 3 plus 2 root 2 plus 3 minus 2 root 2, this is always even. This is always even. Okay, so let's say if this is I plus f, that means integral part plus the fractional part. Okay, and let's say if this is g, then you know that f plus g is equals to 1. F plus g is equals to 1. Then what is f? F is basically, f is 1 minus g. So that's basically 1 minus 3 minus 2 root 2 whole to the power n. This thing we have done quite a few times in your binomial theorem, this particular concept. The real part and the fractional part. Now you take the limit n tends to infinity. Now you take the limit n tends to infinity. So this is basically, if n tends to infinity, then obviously this will tend to what? 1. Right? This tends to a 0. So obviously this is 1. So this is equals to 1. Okay. Last question. Last one. Px is Px is x cube minus 3x square plus 2x, where x belongs to R. F0 is what? F0x is. Many have not done this question, but this is a very, very easy question. Many have not done this question. Seeing the nature and the size of this question, many have left out this. X is greater than or equals to 0 and minus of x to 0 pt dt when x is less than 0. Acha, see f1x, if you see this, f1x is e to the power f0x. Then you have f2x is e to the power, what is this? F2x is e to the power f1x, and so on. You have up to fnx. Fnx is e to the power fn minus 1 x. The question is, how many roots does the equation dfnx upon dx equals to 0 have in the interval minus infinity to infinity? Right? So this equation dfnx divided by dx is equals to 0. First, understand this question. This is such a simple question if you see. First of all, what is dfnx? You have fnx. So this is basically d by dx of fnx is what? Fnx is e to the power fn minus 1x. Right? If you find the derivative of this, e to the power anything, this will remain to be e to the power that thing only, so which is e to the power fn minus 1x multiplied by the derivative of fn minus 1x, which is fn minus 2, isn't it? Which is fn minus 2, right? Then again, This process will continue. This process will continue, isn't it? So basically, if you keep on finding the derivative of this function is what? E to the power fn minus 1x. This is e to the power fn minus 1x multiplied by fn minus 2x, right? Fn minus 2x. And then again fn minus 2 is some function, and if you find the derivative of that function, again e to the power that function, so that thing will come down, and again the this thing will get reduced. E to the power fn minus 1 will get reduced. So basically the thing is, ultimately what you are having is e to the power fn minus 1x, this will remain the same, and e to the power fn minus 1x is never equals to 0. This is the thing which you already know, right? E to the power fn minus 1x is never equals to 0. And if you keep on differentiating this, the thing is, ultimately what you will get is, finally you will have f of 0, f prime 0, f0 prime is equals to 0 only. You will get back this function, the main function f1x, f0 prime x is equals to 0. You will get the main function. You will get back this thing only, f0. You will get back f0 prime x is equals to 0. If you keep on going by this process, f0 prime x is equals to 0. If f0 prime x is equals to 0, which means, this means what? What is f0x? F0x. So basically you are simplifying your question 2 in the form of dfnx upon dx is equals to 0. So basically you are simplifying your question into the form of, so ultimately see how you are simplifying this question. So this question is now reduced to f0 prime x is equals to 0. And what is f0 prime x? F0 prime x, first of all, f0x is this. So what is f0 prime x? F0 prime x is what? Integration of 0 to x pt, and this is minus of integration x to 0 pt dt. You can see that what is f0 prime x? F0 prime x is px only. You will get px only from here, right? Isn't it? You will get px only. So this is what? This is ultimately you have px is equals to 0 only. You get back this px only. Px is equals to 0 only, which is x cube minus 3x square plus 2x, which means this means x cube minus 3x square plus 2x is equals to 0. So how many solutions will this have? Obviously, in between minus infinity and infinity they have said. How many solutions? 3 solutions only, maximum. How many roots this will have? 3 roots, obviously.